Okay, we are dividing today. We talked a little bit about it yesterday. So let's go through our thing real quick. So if we have like a to the fifth times a to the third, what does that equal? A to the eighth. So we just multiply them together, or add the exponents. When the bases are the same and they're multiplied together, you add the exponents. What if I have a to the fifth to the third?
A to the 15th.
A to the 15th. Multiply the exponents in that case. And then we talked about this a little yesterday, but a to the fifth divided by a to the third is a to the second. Okay, didn't talk about this as much, but a to the third divided by a to the fifth.
A to the negative second time?
Okay, it is a to the negative second, but here's the thing. A lot of these problems, they like to say, do not leave your answer with negative exponents. Well, how do I write this in a way that it's not a negative exponent?
1 over flip it.
Okay, here's what's happening. When you multiply those out, that's a times a times a. There's 5 of them down at the bottom. They cross out, and you're left with 2 a's on the bottom. So that's like 1 over a squared. Okay, because 3 of these cross out with 3 of these, but that still leaves 2 on the bottom, so it's 1 over a squared. So 1 over a squared is the same thing as a to the negative 2. Have we talked about negative exponents before? I feel like we mentioned it once, a long time ago. In chapter 1, we talked about it briefly. You guys didn't really master it back then, but a negative exponent just means you flip it to the other side. What do I mean by flip it? Well, a to the negative 2 is like a to the negative 2 over 1. So if we flip it, it's 1 over a squared, and it's no longer a negative exponent. So like, what's 5 squared?
5 times 5.
So it is 25. So 5 to the negative 2
1 over 25.
is 1 over 25, not negative 25.
So you want us to write
Okay, if there was a negative out here, that would be negative 25. But in this case, it's 1 over 25. It kind of depends on what the directions tell you. It's more common for them to tell you, do not leave a negative exponent. So if we get an a negative 2, we're going to have to change it to a to the 2 on the other side. But sometimes they say just leave it. So it just depends on the direction. We'll talk about it as we go. Number 1. Well, it starts off easy. Jackson, what do you think this will be?
Divide
18 divided by 2 is 9. What's x to the 7th divided by x squared?
18.
X to the 5th. Yes. So we just subtracted 7 minus 2 for the exponent. So easy, right? If they were just all like that, you guys would have a nice day. Okay, on number 2, does 36 and 24 divide?
No.
So what do you think they want you to do with that? Reduce the fraction, and which is what we're going to have to do on number 3, because 12 and 16 aren't going to divide either. Okay, on number 3, so I didn't read the directions. It says simplify, leaving each answer in positive exponential form. So if we do get a negative exponent, we do have to fix it on this first section. All right, Hank, what can I do with negative 12 over 16?
Good question. You divide it. I don't know.
Okay, does 12 divided by 16? No, but what can we do? We can reduce it. So what do these both divide by? Also, if you put it in your...
4.
Yes, they both divide by 4. Also, you can put this in your calculator and just hit as a fraction and hit equals. But if you divide them by 4, you just get negative 3/4, right? So that's what we're gonna do. Okay, now I made my fraction bar longer because we got some letters over here. All right, Hank, what will we have with the A's?
1.
A to the 1, which is just A.
Which is 5.
Right. So if there is no exponent, that's just like a 1. It's not nothing. By the way, what is like b to the 0 equal to?
1.
1. Okay. But yeah, b is like b to the 1. So 6 minus 1 is b to the 5th. I could have also written this, and you guys don't need to do this. We're not going to be doing this part. As ab to the 5th kind of off to the side. You can think of them as being in the numerator, because it's like they're on top of a 1. But yeah, I'm just going to be putting them all in the same fraction for this part. Anyways, okay, number 5. All right, not a lot to do on this one. Okay, we're not supposed to leave a negative exponent. I didn't really talk about what if the exponent is negative in the denominator. What do you guys think is going to happen? If it's negative in the denominator, what are we going to do about it? Right, we're going to flip it, so that means it's actually going to go to the top. It's going to be positive in the numerator. So it's like z squared over 1, but z squared over 1 is just z squared. Here, I'll show it open. Okay, so if it's in the numerator and the denominator is just 1, you don't really need a denominator, right? Because like 7 over 1 is just 7, right? So dividing by 1 doesn't really do anything. All right, does that make sense? So I just flipped it to the other side. It's z to the positive 2 on the top, which is just z to this z squared. Yeah, if the bottom is empty, it just becomes a 1. Or if the top is empty, it's a 1 on these. Okay, number 7. If I remember right, which I might not, but I feel like something like this is on the test, which is not, we're not that close to it, but we just finished a test. What do you think? Any ideas? Okay, if we think of this as a fraction, this is just all over 1. Okay, so this is just a numerator. If it's not a fraction, it's just on top. Okay, so I need to fix the x to the negative 3rd. How am I going to fix it? Because they said no negative exponents. I'm just going to move it to the bottom, and it's going to become 1x to the 3rd, or just x to the 3rd on the bottom. So notice, is the negative exponent, is it on the 2? Does this apply to this? No. Not unless they put like parentheses around all this. It only is on the x. So only the x is going to move. Okay, number 9. All right. You have a question? Did I write the wrong one down? No. Okay. Sophia, what do you think about this one? Leave her alone, guys. My word. Huh?
Do you flip them and then minus them?
Yeah. Yeah, she said flip. Yeah, you can flip them both since they're both negative. And it'd be like x to the 3rd over x squared. and then you subtract the exponents. But also, you could just subtract from the beginning. You could just do -2 minus -3. You gotta be careful though, when you're subtracting with negatives, that usually confuses people. So, what's -2 minus -3?
1.
+1, right? Because this is like a plus. So this is just x to the 1, which is just x. But yeah, what Sophia said was right also. So it's like x to the third over x squared. And then if you subtract the exponents, you get 1. So it's just x to the 1, which is just x. Number 11. A4, A2, A5, All right, Jonathan, what do you think about this one?
Would you add the A's, like A to the fourth, A to the second, and A to the fifth, and A, and make it A to the sixth, and A to over A to the sixth?
Right. So yeah, these two, since we're multiplying up these two, you could add those. So it's a to the 6 over invisible 1 right there, a to the 6.
Would you subtract 0?
Well, you get a to the 0, which is what? 1. Okay, what's anything divided by itself going to be?
Remember?
No. 1. Like, what's a million divided by a million? 1. What's a to the 6 divided by a to the 6? 1. It is a to the 0, but anything to the 0 power is 1. This is kind of why anything to the 0 power is 1. Because you subtract exponents, and if your exponent is 0, that's the same thing as just equaling 1. Anyways. Okay, 13. Goodness sakes. X squared y -5 cubed. Okay, this one is more like yesterday's. What did we, Bo? What did we do yesterday with the exponent out here? Do you remember?
Multiply?
Yeah, we did. And we multiplied both of those. So this is x6y to the -15. If you multiply both of those. But we can't leave a negative exponent. So Bo, do you know what we're going to do about that?
You make it, would you put it into a fraction?
Yes.
Would it be like 1 over y to the 15th?
Well, that's part of it. That part is that, yes.
And then you bring the x over?
Okay, so x to the 6 isn't going to go anywhere. And basically it's, right now, over here it's on the top. So it's just going to stay on top. So 1 times x to the 6 is just x to the 6. We don't really need that 1 right there. So the top just stays x to the 6th, and the y to the 15th moves to the bottom. Thanks. 15. X over y cubed. It's gray. Okay, what's x over y cubed? Where are we at? Mallory. Any ideas? Yeah, you can think of this as distribute. Like, we're supposed to multiply 3 of these together, right? Like that. So it's really like x times x times x over y times y times y. So it's really like x cubed over y cubed. Yes. Which would be x cubed over y cubed. There's not really anything you can do about that. Just let it happen. What if the exponent had been negative? What if that had been a -3 right there?
Would they both go on
No.
1?
Yeah. Well, it would kind of be like that, right? So you just flip them both. So it'd be y cubed over x cubed. It's almost the same thing, just upside down. Is it 10:10 on Wednesdays? Anybody remember?
It should be a 3-day assignment.
Should it? Or a half-day assignment?
It should be like an effort assignment.
An effort.
Like
What if I judge your effort as lacking?
a 5-minute.
Just make sure.
Okay. Divide by 2xy. All right. So we're in a new section, so we should probably read the directions for a second. It says, simplify leaving all variables in the numerator. What that means is we're not going to change negative exponents. We're just going to leave everything on top, like normal. So no fractions. I feel like a lot of these problems are easier. Wait, did I copy this wrong? Yeah, if you write it in fraction form, but technically the way they wrote it, it should not be a fraction.
Is that a 4 or a 9 up?
But they did, how they should have written it is like this, actually, because that's what they meant, based on their answer. Because the order of operations, you should only divide the 2, not the x, unless you put it in parentheses. Anyways, okay, they screwed up a little bit. So, this is usually an easier way to see the problem, kind of like the first. So it's 16 divided by 2 is 8. Oh, whose turn again? Josiah? Where is your paper? You should be following along with us. Okay, Josiah, do you know what this would be right here?
No.
Alright. X to the 6 divided by x. Leah, you haven't been here, so I won't call you. Corbin, how about the x's? There.
Wait, the x's?
Yeah.
You would, subtract, I guess.
Yeah, so it's 6 minus what?
A 1.
1. Yeah, so there are 6 minus 1 is 5, so that's x to the 5th. And then for the y's, that's supposed to be a negative 4, so it's negative 4 minus 5, negative 4 minus 5, negative 9. Okay, the difference on this section is we're not going to change that. Right now they're all in the numerator because it'd be like over 1. Okay, we don't really need that though. We're just going to leave it like that. So that's what's different about this second section. Maybe a little bit easier in some ways. 19. Okay. So I'm just going to write it with the division bar. That's what they actually meant, not the division symbol. You could use the division symbol if they had used parentheses along with it. 20 A6B2C7. Okay, AJ, can we do 4 divided by 20? Is that going to work?
Yeah.
Well, 20 divided by 4 is 5, but what's 4 divided by 20?
2.
Well, we're not going to do decimals. 4 divided by 20, if you divide both of those by 4, is 1 over 5 instead of 5. So anyway, that part's just going to be 1/5. Just reduce it a little bit. AJ, how many A's are we going to have?
12.
No? What do we do with division?
Subtract 0.
Right. A to the 0. And A to the 0 is 1. And 1 times whatever is just whatever. So the A's just kind of go away. A6 divided by A6, that's gone. And then for the b's, we have negative 7 minus 2, which would be, no, that's like left 7, left 2, right, on the number line. Left 7, left 2, so where are we at? Negative 9. And then we have 2 minus 7 for the c's, so that's negative 5. Okay, that's the answer, do not write this next part, but in the other section, this would just be 5 on the bottom and then B9 and C5 on the bottom, so it would look like that if this is in the top section. But they told us just leave everything on top, so anyways. How far did I say we're going? That was ambitious of me. You agree? I might have a little bit of mercy.
Mercy.
Except for Brianna.
Wow.
I mean, I understand.
I can see what you're coming from.
Lost my place. Negative 2a, negative 2b3. Let's just do 24, I guess.
Yay.
Okay. Let's see. I kind of looped around that way. Okay, well, I'll just ask the class. So we've got 10 divided by negative 2. So what's that going to be? Negative 5. All right. Well, I'm going to do this in alphabetical order. There's no a's on top. There's just an a to the negative 2 on the bottom. But if we're supposed to leave everything in the numerator, that means we need to put the a on top. So this one, actually, we do need to flip to the top as a to the positive 2. All right. For the b's, what am I going to do with the b's here? Subtract. Negative 2 minus 3. Negative 5. That's like left 2, left 3. So it's all the way to negative 5. If you still struggle with these, just use your calculator. Make sure you got it right. B negative 5. C4, can I do anything with that? It's already on the top, so we're just going to leave it alone. C to the 4th. No, I said 24 already. Yeah.
Thanks, Mr. Jordan. Thanks.
Okay, 23 goes back to positive exponential form, so that means no negative exponents, so just like the first section. Does negative 6 over 7 reduce or divide or anything? No, so we're not going to really do anything with that part. Y2, Y2, Z3, Z2. Okay, so yeah, negative 6/7 does not reduce. So I'm just going to put that out in front. I don't think we need that long. Okay, for the x's, we have 5 minus 2, which is 3. The positive 3, so I'm just going to leave it on top. For the y, is that a 7? I kind of forgot what that was. That was a 2. Okay, for the y's, we have 2 minus 2. 0, well, it's y to the 0 is 1, and 1 times that is just that. So it just kind of disappears. Okay, z is 3 minus 2, which is z to the 1. If it had been 2 minus 3, it would be negative 1, which means I just would have put a z on the bottom. But since it's a positive 1, It's gonna go on, stay on top.